Okay, class, so for today's lesson we are going to talk a lot about reference angle, and a reference angle is a positive and acute angle, and we call it theta prime, so the Greek letter theta prime, and it's formed by the terminal side of an angle. So remember, for an angle we have the initial side, which is the positive x-axis, and then the terminal side, and we open up the angle. So it's always formed by the x-axis and the terminal side of our angle. So this angle happens to be its own reference angle. But if you have an obtuse angle in quadrant 2, we have the terminal side here in quadrant 2, and we draw a perpendicular to the x-axis, and we'll be talking about this reference angle here. So this angle here in that triangle is our theta prime. For an angle that is over in the third quadrant that has its terminal side there, if we draw a perpendicular to the x-axis, then we'll be looking at this angle amount here, and that is what is going to be the reference angle for any angle in quadrant 3. And if you have an angle that's in quadrant 4, where its terminal side is in quadrant 4, the reference angle would be the small one inside this triangle here in quadrant 4. So depending on where the terminal side of your angle is, if it's quadrant 1, the angle is its own reference angle. If the angle is the big one here, the obtuse one, the reference angle is the acute one here. If you have this large obtuse angle more than 180 degrees, the terminal side is in the third quadrant, so that's your big theta. Your theta prime, your reference angle, is this one here that's formed between the terminal side and the x-axis. And then if you have this large angle that's more than 270 degrees where the terminal side is in the fourth quadrant, the reference angle is the small one in the triangle that's formed between the terminal side and the x-axis. So always form between the terminal side of the angle and the x-axis, and that will be your reference angle. Okay, so for this example, we are going to find the reference angle for a 190 degree angle, and if we draw a 190 degree angle, I know it's down here because we went 180 degrees and 10 more. So the reference angle is the one that's formed here, and that will be our theta prime. So our theta prime is just this angle in here, theta prime, and that is 10 degrees. Okay, because our theta was 190 degrees, and the distance between the terminal side and the x-axis was just 10 degrees. So here we have a negative 145, so we're going to go in the clockwise direction, and we're going to go minus 145 degrees. So we're going to go this way. So here's my terminal side. So we always draw from the terminal side a perpendicular to the x-axis. And then the reference angle is the angle between the terminal side and the x-axis. So here is my reference angle theta prime. So if half the circle is 180 and this theta, we want 145 degrees, 180 minus 45, 145 would be 35 degrees. So the reference angle is 35 degrees. My theta prime is 35 degrees. Remember, the reference angle is always a positive and acute angle. Okay, so we're kind of like looking at the absolute value of those two. Okay, so then we have it in radians. Let's draw the angle 2 pi over 3, and I know 2 pi over 3 is 120 degrees. This is my angle theta, so to find the reference angle, you draw the perpendicular to the x-axis, and the angle between the terminal side and the x-axis is your reference angle. So my reference angle is this yellow one here, theta prime, and since the half circle is pi, and the theta is 2 pi over 3, if I subtract, my reference angle is pi over 3. So pi over 3, because pi over 3, my theta prime, plus 2 pi over 3 makes pi, because that was the half circle. Okay, so for part D, we have minus 11 pi over 6, so I'm going to split it into 6. So if I have 1, 2, 3, 4, 5, 6, and then I can continue 7, 8, 9, 10, 11, 12. Okay, so split it. I can have the lines drawn out. That just gets really messy. So minus 11 pi over 6, that's 6, 7, 8, 9, 10, 11, which would be here. So minus 11 pi over 6 would be that one. Draw the perpendicular to the x-axis, and the reference angle, your theta prime, is the one between the terminal side and the x-axis, which happens to be in quadrant 1 this time. So my theta prime is the measure of this angle, which is always going to be positive and acute, and that is going to be pi over 6. So that is my reference angle. Okay, let's go on to the next problem. So in this example, we want to find sine of theta given that tangent of theta is negative 3 and theta is in quadrant 2. So I'm going to start off by drawing a diagram where I have an angle theta in quadrant 2. So my angle theta is something like this. We are going to use reference angles. So whenever we have some sort of obtuse angle, I want to have some sort of triangle. So this is going to be my reference angle inside the triangle. So if I want to find sine of theta, I can look at the reference angles triangle and help us that way. So now I drew my angle theta in quadrant 2. So now I'm going to use this bit of information. Tangent of theta is negative 3. And I know tangent of theta is negative 3. And tangent using SOHCAHTOA is opposite over adjacent. So I'm going to write minus 3 as minus 3 over 1, so I have an opposite and adjacent. Okay, now if I'm looking at my triangle here, I know my opposite is a positive number, but my adjacent would be a negative number. Kind of think unit circle wise, I went left, so it's negative, I went up, so it's positive. Okay, you can also think of it as tangent is y over x, the y coordinate over the x coordinate, and my x coordinate is negative and my y coordinate is positive. So I'm going to make my 3 positive and my y negative. This still reduces to be negative 3. So I'm still using tangent as negative 3, but what that tells me is my adjacent is negative 1 and my opposite is y, or positive 3. So tangent of this is 3 over negative 1. So when we have an obtuse angle theta, we can look at the reference angle to get the triangle to use SOHCAHTOA, or the y and the x coordinates. Okay, so again, we made the 1 negative because we're in quadrant 2, and this is the negative direction. We made the 3 positive because we went up. So we want to find sine of theta. So to find sine of theta, we can use this reference triangle because it tells us its distance left and its height up. So using SOHCAHTOA, sine of theta is opposite over hypotenuse because we're using the SOH part of SOHCAHTOA. And I'm going to look at the reference angle. The opposite is 3. And its hypotenuse, well, we have to find the hypotenuse. So to find the hypotenuse, we are going to use Pythagorean theorem. So I know that the hypotenuse squared is 3 squared plus minus 1 squared. So the hypotenuse is the square root of 10. 9 plus 1 is 10. So the hypotenuse is square root of 10. So it's 3 over square root of 10. So I'm going to rationalize. So we have 3 root 10 over 10, and that is the simplified answer. So the next set of exercises, we are going to need a calculator. So I want you to read the directions in its entirety and grab your calculator. I'm going to highlight what we need. We are going to find our answers rounded to the nearest whole number between 0 and 360 degrees. So the steps we're going to take are these. We're going to determine the quadrant, then we're going to that the 2 angles lie. We're going to use the calculator and to find one angle and round to the nearest degree. We're going to sketch it and label it. Then we're going to use reference angles to find the second angle and then calculate using reference angle. And we'll come back to this. Okay, so for the first example, okay, so we're going to find the 2 angles that make this statement true. Sine of theta is 0.8191. So sine is a positive number. All I need to take from this right now is that it's a positive number. So remember, we know that sine on the unit circle is the y coordinate, and over here both of them are positive, and over here the x coordinate is negative, but the y coordinate is positive. So I know sine is positive in the first 2 quadrants. Okay, because sine is how far up you go, and when those are up, and in the bottom two quadrants, it goes down. So if I sketch my two angles, I know one angle is going to be this angle, and I'm going to call that theta 1, and then I'm going to have a second angle, and for this example, my second angle is in quadrant 2, and it's this much here. All of that is my theta 2. Everything that's red is my theta 2 angle, because both of these have the same height, so they're going to have the same y value, how high up they go on the unit circle. Okay, so what we're going to do is we're going to use our calculator to find the angle that makes this true. So in order to do this, we're going to use inverse properties, and theta is the sine inverse of the number 0.8191. And we're going to type this into our calculator. We want our answer in degrees, so we're going to have to go to the mode and make sure we are in degree mode. Okay, so we're going to pull up the calculator now. Okay, so we're going to press mode on the calculator, and then we're going to confirm that we're in degree mode by using the arrow keys and pressing enter on top of degree, and then we're going to quit out of it. And then to get sine inverse, we're going to press second, and then sine. See how in blue on my calculator it's blue in the blue second button? That gets us sine inverse of 0.8191. And then we're going to press enter, and it's going to give us the angle theta, and we're going to round this to the nearest degree, which is 55 degrees. So that is our first angle. So my theta 1 is 55 degrees. So let's find our second angle. So if this much is 55, and then we had our second one, I know that this, because they're the same height, is also 55 degrees using reference angles. What I really want to do is I want to find my red angle, my theta 2, which is this much. This is my theta 2. So to find theta 2, in this particular example, theta 2 is 180 degrees, right? The half circle subtracting this 55. Subtract the 55 degrees from the reference angles, and I know that my theta 2 is 125 degrees. So I found my two angles, my theta 1, which is theta 1 is the first one that I got out, which is 55 degrees. So if this is 55 degrees, my reference angle for my theta 2 is this much, which is 55 degrees, and everything else, 125 degrees is my theta 2. Okay, so let's do one more example. Okay, so for this angle, we need to find where cosine of some angle is a negative number. So cosine is negative in quadrant 2, in quadrant 3, because cosine is the x-coordinate. So my theta 1 is going to be this much, and then my theta 2 is going to be this very large angle that goes down into quadrant 3. And we are going to, theta 2. And we are going to be using reference angles, and I know that this much is going to be equivalent to this much here, because those two are the same triangle. So let's go ahead and find our theta 1. So to find theta 1, theta 1 is cosine inverse of negative 0.8476. So let's type that into the calculator. So second cosine of negative 0.8476, and press enter. And we get to the nearest degree 148 degrees. So my theta 1 is 148 degrees, and that seems reasonable. And if you check cosine of 148 degrees, you get out negative 0.8476. We got 0.8 because we rounded. Okay, so that is my theta 1. So to find the theta 2, I need to use reference angle. So this yellow bit in here is going to be the reference angle, which is 32 degrees, because 32 and 148, and this is going to be 32 degrees. So I know my theta 2 is going to be 180 degrees plus 32, or 212 degrees. So those are the two angles, and you can check it on your calculator. So have a great